Hey everybody, today we're going to be talking about body systems. This is PowerPoint number 1, so here we go. Now, first thing we need to talk about is homeostasis. Homeostasis is maintaining a relatively constant internal environment. Okay, so it's just keeping things in line and in check. Things like body temperature, blood pH, blood sugar. Remember, your body temperature needs to be around 98.6 degrees Fahrenheit. Your blood pH ought to stay around 7.4. Your blood sugar should be 0.05% to 0.08%. And homeostasis is just a way of maintaining a stable, constant internal environment. And if things change a lot, then there are conditions and things in place to keep everything in the same place or move it back to the same place very quickly. Now, the first way that we do that is through negative feedback. Negative feedback is the main mechanism in our body that keeps everything that's a variable, like blood sugar, close to a set point. And first you have a sensor or a receptor that monitors a physiological value and is going to report it to the control center. Okay. And a sensor can be sensory nerves or something like that. A control center most likely is going to be your brain, and your brain is going to send a message to an effector, which a lot of the time is an organ or gland that's going to cause a change to reverse the situation and move the values back to the normal range. Now, here is the feedback loop that basically shows how homeostasis, let's say, is, your blood sugar is just fine, and then you eat a whole lot of sugar, you eat way too many candy bars, and basically a message is going to be sent because your blood sugar is way too high, and the sensor, your blood sugar, will send a message to your brain, and your brain will send a message to your pancreas to lower your blood sugar down, and basically your pancreas will just release lots of insulin. And when insulin is released, it's a hormone, it will lower your blood sugar levels, and blood sugar will return back to normal, and you will resume homeostasis. Okay, and once everything's back to normal, the pancreas is not going to be stimulated anymore to secrete insulin, and that generally happens every time, right after we eat. Now, here's another example of negative feedback. This is body temperature. The top loop here, if you have normal body temperature and then you go outside, well, it's very hot that day. Let's say it's 100 degrees. The nerve cells in your skin and your brain will send a message to your hypothalamus, which is your control center for body temperature, and it will send a message to your skin, and your blood vessels will dilate, your sweat glands will secrete, you'll start to sweat, and you will cool back down and return to normal temperature. And in the different way, if you get too cold, then the nerve cells in your skin and your brain will send a message to your hypothalamus in your brain, and that will send a message to your skin. Your blood vessels will constrict, your sweat glands will go inactive, you'll start to shiver, okay, the hair on your arms will raise up, and that will raise up your body temperature, and things will return back to normal. Now, positive feedback doesn't happen as much in our body, but that's a change that basically brings about a greater change in the same direction. The two classic examples are blood clotting and childbirth. Now, when someone is bleeding, the platelets will all be activated and they will rush to where the cut is, and they will help clot up the blood so that you don't continue to bleed. And then once the blood is clotted and you're starting to form kind of like a scab, then the platelets will just be inactivated and you'll stop clotting. And in the same way, childbirth, when a woman is giving birth, the contractions will get stronger and stronger until she gives birth to the baby. And then once she does that and the placenta comes out, then those contractions will shut off. Okay, so there's a definite cutoff point, for positive feedback, and this doesn't happen all the time. Now, organ systems, there are several organ systems that we need to know. The integumentary system, that is skin, hair, and nails. and it helps protect our body and helps control body temperature and synthesizes vitamin D. Okay, helps us with sensory input. Our digestive system helps process food and nutrients and eliminates waste. Cardiovascular system transports blood, nutrients, and gases through the body, and also helps us maintain, body temperature and other things. Now, lymphatic is very important for immunity and fluid balance. Your respiratory system is very important for gas exchange, okay, and helping us breathe. Urinary system mainly deals with waste, pH balance, water balance. Your skeletal system is very important for structure and also helping us move. And likewise, the muscular system also works with your skeletal system for movement and helping us, stand up straight and helping us keep our body temperature nice and stable. Okay, it does produce heat. Your nervous system sends messages from your brain and your spinal cord out to your peripheral nerves. And then those peripheral nerves send messages back to the brain and spinal cord. And your nervous system is very important for coordinating your organ systems and also for, skeletal muscle movement. And then finally, your endocrine system helps produce hormones. It helps you go through puberty and menopause. It helps regulate your metabolism. And then your reproductive system also works with your endocrine system to make hormones and also, of course, helps us have offspring. Now, transport systems, okay, your cardiovascular system, okay, which is really your heart and your blood vessels, that's going to carry blood around, okay, through the capillaries where you get exchange of gases and nutrients and waste. And then you also have tissue fluid, which is going to just make sure that the cells have everything that they need, okay, like oxygen and nutrients, and they'll also move wastes out like carbon dioxide and ammonia, nitrogen, things like that. Now, this is just kind of a picture of your capillaries and where gas exchange occurs. Basically, oxygen and nutrients are going to go out to the cells, and then carbon dioxide and waste get picked up by your capillaries where they are put into the bloodstream, and then we exhale and blow off our carbon dioxide, okay, and a little bit of water vapor too. Okay, so this is where gas exchange occurs. These are these tiny little blood vessels way deep down in our body. Okay. Now, there are maintenance systems to keep everything in check. You have a respiratory system, of course, to help you bring in oxygen, remove carbon dioxide. You have a digestive system for processing our nutrients and calories. You have your liver, which removes a lot of toxins, helps regulate your blood composition. And then you have kidneys, which are very important for maintaining blood volume, salt and pH balance, and also removing waste. And then finally, you have support systems like your skeletal system, like integumentary, to help us store minerals and produce blood cells and vitamin D, okay, protect our organs. And then the control systems like your nervous system and your endocrine system keeps everything moving and helps basically coordinate your other organ systems. Okay. Now, the first system, your integumentary system, that's really skin, hair, and nails, and also your sweat and oil glands. And the functions of it are to protect from trauma, water loss, and bacteria. Helps us regulate our body temperature and helps us make vitamin D. And it also helps us have sensory receptors so that we know what's going on around us. The three big layers of the skin are your epidermis, your dermis, and your subcutaneous layer or your subcu layer. It's also called the hypodermis. Okay. Your epidermis is the top layer of skin, and mostly it's got a lot of dead cells in it. And it's also got melanocytes, which help produce the pigment melanin, which helps determine how dark your skin color is. Okay. Your dermis has a lot of collagen, a lot of elastic fibers. It's got some blood vessels in it that will help nourish the skin and get nutrients out to the cells. It's also got a lot of sensory receptors for pressure and pain, okay, helping you feel your clothes when you put them on, things like that. And then the subcutaneous layer, that's got a lot of fat tissue in it, which is very important for energy storage and helping us not bruise as easily if you bump into something. Okay. Just an aside, when someone gets a tattoo, that tattoo ink actually goes down in the dermis. Okay. And that's one reason why tattoos do not go away. They are permanent because the ink gets basically kind of fixed into the collagen and the elastic fibers. Whereas if someone gets a suntan, those tan lines will fade over time. And the reason is because basically the sunlight only affects the epidermis, and we are constantly replacing our skin really every 28 to 30 days or so, which is one reason why you have to keep going back. If you go to the tanning salon, which you shouldn't do, okay, it's bad for you, but if you do go, that's why you have to keep going back, because tan lines fade. This is what your skin looks like. Okay, those are the top layer here. You've got your epidermis, and then your dermis, and then your hypodermis, which has a lot of adipose tissue, or your subcutaneous layer. Okay, and here we can see oil glands, we see sweat glands. Okay, there's an oil gland right here. Okay, sweat pores are right there. There's a sweat gland. Okay, there's erector pili muscles, which will help your hair on your arms raise when you're cold or afraid. A lot of things like that. Now, accessory organs are hair follicles, which basically help you have goosebumps. Okay, and you have hair follicles, which are underneath the skin. The hair shaft is above the skin. You have oil glands, which will secrete oil or sebum to lubricate the hair and the skin. You have sweat glands to help you calm your body temperature back down when you get too hot. And then you also have nails just for protection, from bacteria and also from trauma. And those are, of course, at the end of your fingers.